Now we're going to learn about rationalizing the denominator. If you ever encounter something like this, 16 over the square root of 2, it's not incorrect like it said in the notes. But if this were a standardized exam, this would not be an option for one of the answers. They would rationalize the denominator, meaning they would get rid of the square root that's in the denominator. So what we're going to do is we're going to learn how can we do that and still keep the problem the same. So we're going to multiply by something that's going to get rid of that square root of 2, namely another square root of 2. But you want to multiply by the same thing in the numerator because square root of 2 over the square root of 2 is just a fancy version of 1. And when you multiply by 1, nothing happens. Everything remains the same, so we haven't actually changed the problem. So when we multiply this, now we just multiply straight across, and we're going to get 16 root 2 over 2. And if you remember from your rules about radicals, rational numbers or regular numbers can get together. So 16 over 2 is indeed 8. So this simplifies to 8 root 2, just like it does in your notes. We'll do another example, and then we'll try the 2 from the notes. If you have something like the square root of 10 in the denominator, and maybe you have a 7 on the top. To get rid of that square root of 10, again, you want to multiply by a square root of 10 on the denominator and in the numerator. And we're going to get 7 root 10 all over 10. These 10s cannot cancel. Remember, 1 is a radical and 1 is a rational number. They have no business together. And since the 7 and the regular 10 can't cancel out either, this is as simple as this gets. I understand it's not very satisfying. So let's try one where at least something good happens. Let's give ourselves a little more room. If you have 3 over the square root of 15, just like in the notes, again, make a guess as to what we're going to multiply by. We're going to get rid of that root 15 by multiplying by root 15 over 15, root 15. And we're going to get this as our result. Take a look and make a quick decision over what is allowed to be canceled out right now. The 3 and the 15. If I divide by 3 on the top, I get 1. When I divide by 3 on the bottom, I get 5. So my final answer is root 15 over 5. And again, the 5 and the 15 can't cancel. They're two different types of numbers. So the final example that we want to try would be 3 over the square root of 48. And the reason I give you this is because the square root of 48 can be simplified, but let's just simplify it later. You could make it into 4 root 3, which is what it is. But right now, let's get rid of it just by multiplying by root 48 over root 48. And we're going to get 3 root 48 on the top, and I'm going to get a regular old 48 on the bottom. We could cancel the 3 and the 48 right now, or we could wait till later. I'm going to cancel it right now with a 16. And now we would need to simplify the square root of 48. And if you remember this from the earlier video, you would get, let's do this the quick way. I said it was 16 times 3. Let's use that. 16 is 4 and 4. There's a pair of 4s. So what I'm going to do is I'm going to replace the square root of 48. I'm going to erase it. And I'm going to write 4 root 3 in its place. And now you could cancel the 4 and the 16 if you would like. So this would ultimately simplify to 3, square root of 3 over 4. If you simplify the radical in the beginning and then rationalize it, or you rationalize it and then simplify it, it doesn't matter. In the end, this is what we're going to get. So now we're going to review foiling and multiplying when we have a combination of rational and radical numbers, just so that we can learn to rationalize super fancy denominators. What we want to do is just remember how to FOIL, and it's just double distributing. We're going to take this 2, for example, and we're going to multiply it times everybody in the other parentheses. So we're going to get our first and our outer, and then finally we'll do our inner and our last. So 2 times 6 is 12. 2 times negative root 6 is negative 2 root 6. And then going to the positive 5, root 5, we're going to multiply these two together to get plus 6 root 5. And then we're going to multiply the square root of 5 times the square root of 6, and we're going to get minus root 30. Now, 30 breaks down to 6 and 5, which is 2 and 3. So there's no groups, there's no combinations that can simplify this radical. So unfortunately, again, not very satisfying, this would simplify to this. That's all it is. We can't combine anything because nothing is a like term. Now, that's not always going to be the case. We're going to try an example here where it does work out really well. So what we're going to do is 7 minus the square root of 11 squared. You can't just distribute that squared. I wish. We have to remember that this is what 7 minus the square root of 11 squared really is. So again, you're going to FOIL this. 7 times 7 is 49. And then we're going to get 7 times negative root 11. And that's going to get us a minus 7 root 11. And then we're going to get the same thing again here. We're going to get minus 7 root 11. And finally, you're going to be multiplying this negative root 11 times another negative root 11. And that's going to get us a minus, and an 11 that's going to come out. Because remember, square root of 11 times another square root of 11, there's a pair of 11s in there. So now you can combine like terms. 49 plus 11 is going to be 59, 60. And these two are like terms, so we're going to get minus 14 root 11. And that's how that would play out. But the last example is the one that's really important, and it's going to lead into the next part of notes about conjugates. We've got 3 plus the square root of 5 and 3 minus the square root of 5. And this really looks like a difference of squares. If you remember, when we have things like this, when you FOIL it out, the outer and the inner term are going to cancel out. You would get x squared minus a 5x plus a 5x. Those guys are gone. And then minus 25. Something very similar is going to happen here. So 3 times 3 is 9. 3 times a negative root 5 is going to be minus 3 root 5. Now we've got 3 times a positive root 5, that's plus 3 root 5. And finally, you have plus root 5 and a minus root 5. So a negative times a positive is going to get you a negative. And root 5 times root 5, again, that's the square root of 25. It's just 5. So let's erase that and write it as a nice looking 5. Well, this whole middle term is gone. These guys don't exist, and you just get 9 minus 5, which is 4. So the fast way to multiply when you have something that differs only in sign, like 6 plus the square root of 7, and 6 minus the square root of 7, all you're going to have to do, instead of FOILing it all the way out, is do 6 times 6, which is 36, and then do plus root 7 times minus root 7, which is going to play out to be minus 7. The outer and the inner terms are going to cancel each other out. So go and check the information about conjugates, make a guess as to what you think conjugates are, and we'll learn the rest of the lesson.